I want to talk about is a problem that deals with your cell phones. Okay? So, do you know how your cell phone works? Do you have an idea? So when you want to make a call, so let's say this is your cell phone, okay? And you want to make a call to somebody else, this cell phone. What happens is your cell phone looks for a cell tower that is nearby, okay? And so let's say this is a cell tower, and the person you're calling also looks for a cell tower nearby. And so when you talk, your voice message gets sent to that cell tower, and this cell tower goes through Bell or Telus or one of the networks to that cell tower, and then this cell tower sends the message to the phone. Okay, so that is how one cell phone and another cell phone communicate. It's through cellular towers. Okay? Now, when your phone is sending messages to this cell tower, it uses something called a frequency. Okay? So you know, like radio frequencies, you know, like when you listen to the radio, you put it at a certain frequency, and then you hear a certain station based on that frequency. Okay? So cellular towers use a frequency in order to communicate with cell phones. But I don't know, do you guys even listen to radios?
Yeah.
So when you listen to the radio, sometimes, let's say you're driving and you're listening to the radio, you know how sometimes you start hearing two stations at the same time, or you start losing a station, like you hear like, you know, that kind of noise happening, or you hear like two songs playing on the same frequency. Okay, so that is called interference. Okay, and interference happens when, let's say this cell phone is talking to this tower on frequency number 1, okay, and I have another tower here and another cell phone that is also talking on frequency number 1. Okay? So when you have this situation, what happens is you get interference, and then these messages get confused, because this tower is also hearing this cell phone, and this tower is also hearing this cell phone, so things get confused, and sometimes you hear like noise or other things. Okay? So interference is bad. We don't like interference. Okay? All right, so the problem, the research problem that you guys have to solve is you are working for Bell or Telus or Rogers or one of the cell companies, okay? And then there are many, many towers, okay? And what you have to do is you have to decide what frequency will each tower use to communicate with cell phones. Okay? So let's say I gave frequency 1 to everybody. Well, that's not a good strategy, right? Because if I have a cell phone here and a cell phone there, you look at the communication range of each cell phone, and all the towers that they see are communicating at the same frequency, so then you're going to get interference. Okay? So I got to give different frequencies to each cellular tower. Okay? So let's say I have 100 cellular towers. Okay? Then I could give 100 different frequencies. Right? I could give each one, I could say, okay, tower number 1, you get frequency 1. Tower number 2, you get frequency 2. Except the CRTC charges a lot of money for each frequency. So in order to save money, you want to reuse frequencies. Okay, so you want to find a way to assign the fewest number of frequencies to each of the towers so that no matter what circle I draw, which represents the communication range of my cell phone, there's always one tower that has a unique frequency. Okay, so that's the problem. So as a warm-up, let's think about the situation when you're looking at the towers that are on a highway. Okay, so you're on a highway, and you have a bunch of towers that are along the highway, because we can still use our cellular phones when we're driving on the highway. Okay, so we have a bunch of towers here, and you want to give them numbers. So let's say I say this one is frequency 1, 1, 2, 3, 4, 2, 1, 3. Okay? I don't know, maybe this is a good, okay, so let's say I did this, okay? This is not a good frequency assignment, because look, I can find a circle which contains those two towers, and there is no unique frequency. Right? But if I did this, then this, I think, is a good one. I think no matter what circle I draw, I always have a unique frequency that I can communicate with one of the towers. Okay? So your problem is you have a bunch of towers that are on the line, on a highway, and so if I have, n towers, you want to find the smallest number of frequencies you want to find a strategy to assign frequencies that's the smallest number that's guaranteed to have this property, that no matter what circle I draw, there's always a unique frequency. Okay? And that number will depend on the number of towers. Okay? The more towers you have, the more frequencies you need. So maybe you can find a strategy. So n frequencies is a very easy solution, right? I get 1, 2, 3, 4, 5, up to n, right? So that's a very easy solution. So you want to do better than n. Okay, maybe n over 2, n over 4, square root of n, or whatever. So you want to find something better than n and give a strategy that can assign these frequencies on the highway. Okay? And if you're able to do that, then you want to go into the city. Okay? So highway first, then city. Any questions?
What is n? What's n?
N is the number of points. So for example here, 1, 2, 3, 4, 5, 6, 7, 8. Here n equals 8. Okay? So it's just the number of towers. Okay, I just gave, because that number can be different in different situations, so I just use the letter n to represent it. Okay? I think it's close to 200 in the city.
Could you repeat the question? Because
How many cell towers are there in Ottawa?
okay.
But it also depends on what you define to be Ottawa, right? Just the downtown core, or you include Canada and Orleans, or yeah. Do you have any questions?
Yes. Is the circle always the same size?
No. See, the circle depends on your cell phone. So if you have a cheap cell phone that doesn't have a good transmitter, then your circle is smaller. So the distance, your communication distance is smaller. But if you have like a very strong, good cell phone, then your communication is smaller.
Is there a maximum size or no?
Yes, there is a maximum size, but that maximum size is very, very big. So for example, there are phones that people bring to remote areas which can communicate with satellites. So their transmission range is huge. right? So, but typically, I think it's, I don't know, is it a kilometer or something? Yeah, it's not like a huge distance, so that's why you need to put many cell towers. You had a question?
No.